The goal for this lesson on graphing functions is I can represent relationships between two quantities with function rules, graphs, and tables. We have actually already done this with function rules and tables. So today the new thing is graphs. And you can think about graphs as just a different representation to show what a function is doing or what it looks like. And that's why we reviewed the coordinate grid the other day. So with that said, you should have your notes next to you, and let's dive into them. If you haven't done so already, go ahead and read the essential question for the lesson. Remember, this is the question that we want to be able to answer at the end. What's a linear function, and how do you graph a linear function? Diving right into our notes, that means going right into our notes. Look at the first title. It says graphing functions. That's going to be our task. And the first problem actually says graph the function shown in the table. Notice right now between your notes and what you see on the screen in front of you, what's the difference between the tables? Well, the table on the screen in front of you has parentheses around an input and then its corresponding output. Recognizing that this input and this output form an ordered pair, and I can take that and plot it right on a coordinate grid. So why don't you right now in your notes put parentheses around each input and then its output and plot that? Meaning graph it on the coordinate grid that you see in front of you, which is really just quadrant 1 of the coordinate grid. Now you have the answer right in front of you, 6th graders. So if for some reason you're not graphing what you see in front of you, then you probably want to start over again. But some things I want to point out are all these points, the 4 points that you had to plot, they all are falling into a line. And that's what makes this a linear function. So a linear function is a rule where your inputs and outputs form an ordered pair and they all fall on a line. And we could actually take this line and we could show that it's going to extend down here to the left and it's actually going to keep going up to the right. And you can actually see a lot what's going on in the graph here, going up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. I mean, we could keep going, right? And we would be going down 1 over 1, down 1 over 1. And all of those points would fall on that line, and it's linear. It forms a line. Now, if we were to plot a point based off of this function table, and our point landed right here, let's say, we would know that we've made a mistake because the point didn't fall on the line. And the cool thing about this too is you have two representations in front of you. You have a function table and you have a graph or a visual of what the function looks like. I mean, we could also figure out the rule. What are you doing to your input to get your output? 0 to 5, I think I'm adding 5. Let's check it with another one. If I put in a 1 and I add 5, do I get a 6? Absolutely. So my rule for this table is my output equals my input plus 5. So each one of these representations model the same thing. It's showing the same thing, but it's just showing it through a different way. Let's look at the next example. Questions say, graph the function y equals x, or 2 times x minus 1 for x equals 1, 2, 3, 4. Now you don't have some of the information in your notes that you see on the screen. So first we want to start by making a function table. Fill that in. We need to figure out our outputs. We have our inputs. It's telling us when x equals 1, 2, 3, or 4. We need to figure out our outputs. And so we need to first start by making a function table. And you can see I've already created it, and all the answers are actually in front of you, but let's walk through them. My function table is going side to side, or it's flipped on its side. Feel free to draw one just like mine on the screen, or feel free to draw one that's going from top to bottom. Now we're given our inputs. We're told x equals 1, x equals 2, x equals 3, x equals 4. So we can fill that in on our chart. Now we need to figure out our outputs. Ms. Cleaver, how did you get output when you put in a 1 that the output is a 1? When you put in a 2 that the output is a 2? That y is a 5? That y is a 7 when your input is 4? Well, we got to use a little substitution. We need to use our rule plug in our inputs to get our outputs. So show this with me in your notes. When x equals 1, we need to figure out what our output is. So I'm right here. When x equals 1, how do we get 1? Well, we plug it into our rule. So we go y equals 2, plug in 1 for x, times 1 minus 1. That's going to give us our output. 2 times 1 is 2, minus 1 is 1. So there's my output. Okay, let's do another one. When we put in a 2 for x, so when x equals 2, remember that's my input. When I put in a 2 to the function, what do I get out? Well, let's figure it out. Plug it into the function. 2 times 2 minus 1. 2 times 2 is 4. Minus 1, what's my output? 3. And you can see there it is. So that's how we get our outputs. When we're given a function rule and some inputs, we can use that to figure out some outputs. Then the job is to graph, because the directions say graph the function. So we now know that in our function table we have our ordered pairs. Now my function table is turned on its side, but I'm still going to put parentheses around them, because that just reminds me that, hey, that's an ordered pair. I can pull those out from my table and plot them on a coordinate grid to see a pattern. Again, this is just another representation of this function from the table, or of this function in the equation form. Make sure you have all of this in your notes. And that's all we have for today. The back side of the notes will be finished at another time, or will be given through another video.